Okay, in this video we are going to talk about section 7.1, which is trig identities. The first thing we're going to talk about is what an identity actually is. So an identity is an equation which is true for all values of the variables. So I'm going to write that down. So an equation which is true for all values of the variables. Okay, so an example of or something that's not an identity would be the equation x plus 2 equals 5. Okay, the reason why this is not an identity, this is just a regular old equation, is because if I plug in 3 for x, it works. 3 plus 2 equals 5, and it's good. But another number for x will not work. Like, for example, 5. 5 plus 2 does not equal 5, so that's not an identity. So that's just a plain old equation. You can solve it. You can figure out what x is, but only one number works for x. The example of an identity would be something like x plus 1 squared. Well, if you write that twice and multiply it out, you get x squared plus 2x plus 1. If you multiply this by itself, x plus 1 times x plus 1, you get x squared plus 2x plus 1. So this is an identity, because if you plugged in, let me write this first real fast. If you plugged in 1 for x on this side and 1 for x on this side, you get the same number. If you plug in 7 for x on this side and 7x on this side, you get the same number. Okay, so that's an identity. This is just an equation. So we have these things called trig identities, and there are a lot of them. I am not going to require you to memorize all of them, but here is the formula sheet you will get on your test. I have uploaded this onto D2L. You can print it off. You can make your own version if you want to, but this is all the identities that you get on your test. Okay, so we are going to learn these piece by piece. So like this first section 7.1, we're actually not even getting into any of these yet, I believe. I don't think we're getting into any of these at all. But maybe the Pythagorean, but you actually already know the Pythagorean identity. So cosine squared plus sine squared equals 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. So you already know those three identities. But 7.2 is this addition and subtraction formulas, so on and so forth. So don't freak out yet, okay? So this is a whole lot of information, but we will learn it piece by piece, okay? So I will be referring back to this throughout these videos, and you will get this exact sheet on your test. So, and we'll talk about the test when we get closer to that time. But just know you don't have to memorize these. You get this on your test. Okay, so what we are going to be doing in this section is we are going to be using identities to simplify trig expressions. Okay, so identities can be used to simplify. And that is the purpose of them. So for example, okay, so if I had the problem's directions would just say to simplify. And my problem is cosine of t plus tangent of t times sine of t. I want to simplify that trig expression. Okay, it's not super pretty as it is now, but I can plug in some things that I know about trig functions to simplify this. So if you'll notice, I have a cosine here and I have a sine here, and I can rewrite tangent as sine over cosine. So just real quick before I get into this, let's write down the things that we actually know here. So I'm actually going to write it on the back of my formula chart here. The things that we know that we can plug in. I know that cosecant of theta is the same as 1 over sine of theta. And if you already have a sine in your problem and then you have a cosecant, it might be nice, or it might help to plug this in, and it might simplify it a little bit. I know that secant of theta is the same as 1 over cosine of theta. Okay, I also know that tangent of theta is the same thing as sine theta over cosine theta. And then cotangent of theta, you can write it as 1 over tangent of theta, or you could also write it as cosine of theta over sine of theta. So those are some trig identities that I already know that I can use to plug in here. Okay, so if you'll notice this problem had cosine and sine in it already, and it also has tangent. If I replace tangent with this sine and cosine, I will have some things that I can do with this at that point. Okay, so I'm going to take this problem and I'm going to replace this tangent t with, I know that tangent t is equal to sine of t over cosine of t. Okay, so I'm going to get cosine of t plus sine of t over cosine of t times sine of t. Okay, so from there, we can do some things here. Here I have multiplication. This is a fraction, this is not a fraction. I can write it as a fraction over 1. And multiplication of fractions, remember you just multiply across the top, multiply across the bottom. So this now becomes cosine of t plus sine t times sine t would be sine squared t. Cosine of t times 1 is just cosine of t. Okay, so it's already getting a little bit better. At this point, I have two terms, and it would be helpful if you got a common denominator so that I can make it one term, because one term is always more simple than two terms. So if you'll look, this one has a denominator right now, it's cosine of t. This one also has a denominator, it's a 1. So the common denominator here would be cosine of t. This one already has the common denominator, so I don't need to multiply this term by anything. This one needs the common denominator. The way that I turn a 1 into a cosine of t is by multiplying the denominator by cosine of t. I also have to multiply the numerator by cosine of t if I do the denominator. So now I get cosine of t times cosine of t is cosine squared t over cosine of t. Here I didn't have to do anything to get my common denominator. I get sine squared of t over cosine of t. Okay, and then now that I have a common denominator, I can add these fractions. Again, the way you add fractions is add across the top, keep the bottom the same. So this becomes cosine squared t plus sine squared t on top over my common denominator of cosine of t. Okay, it seems like it's getting messier at this point, but it's about to like super simplify, because I know that cosine squared t plus sine squared t, that should be familiar to you. If you go back to your formula chart and remember your Pythagorean identities, cosine squared of theta plus sine squared of theta equals 1. So I know this equals 1 right here. Okay, so I'm gonna make a little note. Cosine squared t plus sine squared t equals 1. So this now becomes 1 over cosine of t, and that should be something you know that you can make a little bit easier. Just a reminder, 1 over cosine is the same thing as secant, so this whole thing equals secant of t. Okay, so I went from these two terms just to one term here. Okay, so we're going to do another problem similar to that. For some people, I'll just kind of warn you right now, this is not some people's favorite thing ever, okay? It is, I personally kind of enjoy the way it simplifies, but the hard part about it is when you start here, I don't know where I'm headed with it. I don't know, like, do I stop at this point? 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 Okay, so that's one thing that can be kind of frustrating about it, and my only suggestion to you is the way you get good at it is just practicing, okay? So just practice and practice and practice is your best, is the best way to get good at it. And I'm sorry that I can't make it any easier or tell you what your answers are, but hopefully you'll have a lot of videos to watch and a lot of opportunities to practice. Okay, so the next problem that we're going to do is the problem sine of theta over cosine of theta plus cosine of theta over 1 plus sine of theta. Okay, so we're simplifying this. This simplifies down to something much nicer than this. What I would like you to do is to pause the video right now and go ahead and try to start this. If you need a little hint, your first step here is to get a common denominator so that you can combine these two things into one thing. But I would really like you to struggle with it for a little bit, and so that whenever I show you how to do it, you can kind of make sense of that. Okay, so go ahead and pause the video now and come back whenever you either get stuck or after you finish the problem. Okay, so you are back from working on it. You either got to a certain point that you couldn't get past, or you hopefully finished the problem. So your first step here is to get a common denominator, because this is all sine and cosine. There's nothing that I can replace here. I don't have a Pythagorean identity. I don't have tangent or cotangent or secant or cosecant to replace. So there's nothing to do here except for to get a common denominator. Okay, so the common denominator here, this one has a denominator, this one has a denominator. So the common denominator is just going to be both of them. It's going to be cosine of theta times 1 plus sine of theta is your common denominator. So this one already has a cosine theta. It needs a 1 plus sine theta. So I have to multiply bottom and top times 1 plus sine theta. Over here, this one already has a 1 plus sine theta. It needs a cosine theta. So I have to multiply bottom and top times cosine theta. Okay, so for the first one, 1 plus sine theta times sine theta, you're going to have to distribute. So I need to do sine theta times 1 to get sine theta, plus sine theta times sine theta is sine squared theta. Over on bottom, this is just my common denominator, cosine of theta times 1 plus sine of theta. Plus, over here, cosine theta times cosine theta is cosine squared theta. On the bottom, this is just my common denominator, cosine of theta times 1 plus sine of theta. If you wrote your denominator the opposite, the 1 plus sine theta first and then cosine theta, that's fine too, it doesn't matter. But at this point, you have a common denominator, so you can add across the top and keep the bottom. So when I add across the top, there's no like terms to combine, so it's just sine of theta plus sine squared of theta plus cosine squared of theta over cosine theta times 1 plus sine theta. Okay, so now I see this sine squared theta and cosine squared theta, and I know that that turns into 1 because of my Pythagorean identity. Just a reminder, sine squared theta plus cosine squared theta equals 1. That's on your formula chart if you needed to go back to it. Okay, so this piece right here is the same thing as 1. So now I get sine theta plus 1 over cosine theta times 1 plus sine theta. And if you'll notice, I kind of have the same thing on top and on bottom. Sine theta plus 1 is the same thing as 1 plus sine theta because it's addition's commutative, so you can flip it. 3 plus 1 is the same thing as 1 plus 3, right? So this and this is the exact same thing. If you have the exact same thing on top and bottom and all the other stuff around it's being multiplied, like this is cosine theta times that, you can divide it out. It's kind of like the idea of if I had like here's a separate problem. If I had like 3 over 3 times 5, I can cancel out the 3's and I'm left with 1/5 because this is 3/15 reduces to 1/5. Same idea here. So I'm left with cosine theta on bottom. So it's 1 over cosine theta, and that should also look familiar. 1 over cosine theta is the same thing as secant theta. So this problem actually also reduced to secant of theta. It's not the same answer every time, but it happened to be in that case. Okay, so that is simplifying some trig identities. I'm sorry, simplifying some trig expressions, and we use trig identities for it. So you have some problems on your homework like this. The other types of problems you'll see on your homework is actually proving trig identities. So the way we prove trig identities is pretty much the exact same thing. It's just you know where you're headed. You know what your answer needs to be, okay? So I'm going to give you some helpful hints or a little bit like, I guess you could call them tricks that are helpful whenever you're proving trig identities, and then we will have a few problems that we're going to do together. Okay, so for proving trig identities, the way that you want to prove trig identities is you have two sides of your equation here. Okay, so like you'll have, this equals something. You pick one side and you want to turn it into the other side. So the side you want to pick, this seems weird and strange, but the side you want to pick is always the more complicated one. Okay, so we are going to pick one side, and you usually want to pick the more complicated one, and I'll explain all this in a little bit with some examples. Okay, so you pick one side, and then you work to make it look like the other side. Okay, so that's the first thing you're going to do. Another helpful trick is use your identities. So the ones that we wrote on the back of the paper, these identities, or so far we can use the top ones. We're not going to use any of these yet until the future sections. So use identities. Also, it's helpful if you have two things, we've seen this twice already, to get a common denominator. Okay. It's also helpful sometimes to factor. If something factors, it's nice and helpful to factor it. And then also something else that is helpful is sometimes, and we'll do a problem with this, it helps out if you multiply by the conjugate. And if that doesn't mean anything to you at this point, it's okay. We'll explain it in just a minute. Okay. And then one last thing, sometimes if I get stuck, so if you're stuck, it is really helpful to turn everything into sine and cosine. So turn everything you can. So turn all into sine or cosine. And we kind of already did that a little bit. If you need to pause these videos at any point to catch up with what I'm writing, feel free to do that. But we kind of already did that. If you'll see on that first example, we started off with a tangent and we turned it into sine and cosine, so we only had sine and cosine to work with. The next one already just had sine and cosine. Okay, so we are going to do a few of these problems. I think I only have 3 that we're going to do in this video, and then I will make another video with extra examples if you feel like you need more examples. Okay, so the first example we are going to do, or the first identity that we're going to prove, your instructions will either say to prove them or to verify. Okay, so prove or verify is the 2 instructions. Okay, and the problem is cosine of theta times secant of theta minus cosine of theta equals sine squared theta. Okay, so we need to prove this trig identity. We need to prove that this can equal sine squared theta, or sine squared theta equals this. So essentially, it's like I have 2 sides of my equation. Left-hand side, right-hand side. Okay, you want to pick one side and make it look like the other. So I either need to pick the left-hand side, work it all out so that it turns into sine squared theta, or pick the right-hand side, work it all out so it turns back into this. You usually want to pick the more complicated side because it's easier to take something hard and plug things in and simplify and turn it into something easy than it is to take this easy thing and turn it into something more complicated. So you'll kind of notice we already did that. We started off with something complicated and ended up with something easy. Started with something complicated, ended up with something easy. It's much easier to go that direction than it is to go backwards up this way, to turn something easy and make it more complicated. Okay, so in this case, the more complicated side is the left-hand side. And as you're watching other videos and maybe watching things on YouTube or getting help from other sources, just a heads up, some of the terminology or notation you'll see here is LHS, left-hand side, and RHS, right-hand side, and it's telling you, like, we're starting with the left-hand side and trying to turn it into the right-hand side. I would prefer you to work it out like this. If you have already learned this in a previous course, or you took pre-cal in high school and your teacher taught a different way, that's okay also. It's just a lot easier to follow if you have the columns versus like writing steps across like that, okay? But if you just really needed to do it that way, feel free to do that also. It's just easier for me to grade it this way if you do it this way. Okay, so I'm going to take this left-hand side and I'm going to try to turn it into sine squared theta. So looking at this, I would, me personally, if I see parentheses, I would go ahead and try to get rid of the parentheses. The way I would get rid of the parentheses here is by distributing. Okay, so I'm going to distribute the cosine theta to both things inside the parentheses. So I get cosine theta secant theta minus cosine theta times cosine theta would be cosine squared theta. Okay, so from there, let me see what I can do with this, because, let's see, I'm trying to explain how I would do this. Like, I guess looking at this, there's not really anything to do at this point, so I'm going to turn everything into sine and cosine. So secant theta is the same thing as 1 over cosine theta, so I'm going to replace secant theta with 1 over cosine theta. So this becomes cosine theta times 1 over cosine theta minus cosine squared theta. If you'll notice this, cosine theta over 1 times 1 over cosine theta, that's going to cancel out, divide out, or give you 1, however you want to think about it. You end up with cosine theta over cosine theta, and you are left with 1 minus cosine squared theta. Okay, I'm headed over here to try to get back to sine squared theta. That's my goal. That's where I want to end at. So to get there, I have this 1 minus cosine squared theta, and I need to get to sine squared theta. If you'll recognize, this is a form of this Pythagorean identity. This Pythagorean identity, cosine squared theta plus sine squared theta equals 1, I could solve this for sine squared theta. To solve for sine squared theta, you'd subtract cosine squared theta from both sides. So this right here, 1 minus cosine squared theta, is actually equal to sine squared theta. And if you needed to go over that, again, this identity, cosine squared theta plus sine squared theta equals 1. If I solved for sine squared theta, I'd subtract cosine squared theta from both sides. And I would be left with sine squared theta equals 1 minus cosine squared theta. Okay, so because of that, I know that this equals sine squared theta, and now that tells me I'm done. I got to where I needed. This is the same thing as sine squared theta, so this is my answer. Like, there's no actual answer here, like the whole thing is your answer. So I started on this side, I simplified to get back to this side. And the strategies I used here was I used a trig identity, the Pythagorean identity right here. I also changed everything into sine and cosine, and that helped out a little bit also. Okay, so that was our first problem. The next problem we're going to do, problem number 2, I'm going to go ahead and, I'm going to go ahead and use a tissue paper. Problem number 2 is 2 tangent x secant x equals 1 over 1 minus sine x minus 1 over 1 plus sine x. Okay, so we're trying to prove this. You got 2 sides, left-hand side, right-hand side. Pick one side, turn it into the other. You want to pick the more complicated side. So the more complicated side is usually the bigger side, or if the side has more terms than the other, usually it's easier to turn 2 terms into 1 term than it is to take your 1 term and turn it into 2 terms. So I would encourage you to start with this side. You can do it starting with this side. I just feel like it's more difficult. So I'm going to start over here with the left-hand side. Nope, this is the right-hand side, and I'm going to turn it into the left-hand side. So why don't you take this opportunity, why don't you pause your video and work this out and see how far you can get over here, see if you can get to the right-hand side. I just like for you to kind of struggle with it on your own, and then I'll show you how to do it. So pause your video and start working out this problem and get as far as you can, and then come back when you're done. Okay, so you are back from pausing your video. We are going to take the right-hand side and we're going to turn it over here into the left-hand side. So I have two terms here. It is easiest if you get a common denominator so that you can put them together and turn it into one term. So I'm going to get a common denominator. Common denominator here, if you'll notice, this is 1 minus sine x and this is 1 plus sine x. Those are not the same thing, so my common denominator would be this times this. 1 minus sine x times 1 plus sine x. So this one has the 1 minus sine x. It needs a 1 plus sine x. So I'm going to multiply the top and bottom times 1 plus sine x on the first one, 1 plus sine x. On the second one, I'm going to multiply by 1 minus sine x and 1 minus sine x. It's kind of messy, sorry. But once I do that, on top, I get 1 plus sine x over 1 minus sine x times 1 plus sine x minus, here 1 times 1 minus sine x would be 1 minus sine x over 1 minus sine x times 1 plus sine x. Now that I have a common denominator, I can add, or in this case subtract across the top, keep the bottom. Just a heads up, when you are subtracting, that means you need to subtract all those things up on top here. It might be helpful if you distribute your negative. So think about this as a plus a negative 1 and plus a positive sine x. So when I combine like terms, when I add across the top, keep the bottom, I'm left with 1 plus sine x plus negative 1 plus sine x all over 1 minus sine x times 1 plus sine x. So now let's see what we can do to simplify this a little bit. If you'll look on top, 1 plus negative 1 is 0. So those undo each other. And then sine x plus sine x is 2 sine x, not sine squared x, because they're not multiplied, they're added together. So I have 2 of them now. On bottom, if you multiply this out, you may recognize this. This is the difference of 2 squares. Something times itself if one's positive, one's negative, is going to be the first thing squared minus the second thing squared. So technically, your answer is going to be 1 minus sine squared x. This is also called the conjugate. The conjugate is when you have the exact same thing in the parentheses, but one's plus and one's minus. Okay, and if you didn't recognize any of those things, you could also think about it as, let's just multiply it out. 1 plus sine x times 1 minus sine x. When you FOIL or distribute, 1 times 1 is 1. 1 times negative sine x is negative sine x. Sine of x times 1 is positive sine x. And sine of x times negative sine of x is negative sine squared x. And if you'll notice, this negative sine x and positive sine x is 0 when you add them together. So you're left with 1 minus sine squared x. Okay, so the bottom turns into 1 minus sine squared x. And then from here, anytime you ever have a sine squared x or a cosine squared x and a 1, or cosine and sine squared together, that's going to be your Pythagorean identity. So just a reminder, let me find that. Cosine squared plus sine squared equals 1. So that means that 1 minus sine squared, if I subtracted sine squared over here, I would be left with cosine squared here. So this is actually cosine squared x here. Okay, so this becomes 2 sine x over cosine squared, not theta, sorry, x. Okay, we're getting closer. This is where we're trying to end up. We have the 2. Here, I need to turn this sine squared x over cosine, sine x over cosine squared x into a tangent x and a secant x. So the idea here is, how can I turn sine and cosine into tangent and secant? Well, if you remember, tangent is, let me find where I wrote that down a minute ago. Tangent is sine over cosine. I have a sine on top right here, and actually I have two cosines on bottom, right? Cosine times cosine. So I can get a tangent out of a sine in one of these cosines. And then the secant is the same thing as 1 over cosine. Oops, sorry. Secant is the same thing as 1 over cosine. So I can get a secant out of my other cosine. So you're kind of like using your answer to kind of get to where you need to be. It's almost like cheating, but not really, because your answer's already there. Okay, so I want to break this up into, I'm going to think about this as 2 times sine x, and this cosine, I want it cosine squared, I want to break that up into 2 different cosines. Okay, so cosine times cosine is cosine squared, 2 times sine is 2 sine, and then that would just be a 1 on top. And now I get 2 times sine over cosine is tangent, and 1 over cosine is secant, which that is where I was supposed to end up for my answer. Okay, so that was a little bit of a more difficult one. That was not an easy problem by any means. Just to recap, the tricks or the things that I used here was I used a common denominator to get it down to 1 term. Once I got here, 1 minus sine squared x, I used a Pythagorean identity to get cosine squared x. And then at this point, I kind of used my answer to figure out how to get to my answer. Okay. So if you got stuck there, I hope that was helpful. I hope you kind of figured out what you needed to do from there. Again, this is not supernatural for somebody who's never done it. So the way you get good at it is just doing problem after problem after problem. And sometimes it means getting stuck multiple times and then figuring out how to do it. So that's why I'm going to have this video that has a few problems in it, and then I'm also going to have an optional video if you need the extra help to practice more problems. Okay, so last problem we're going to do is this identity, or this equation, cosine of x over 1 minus sine of x equals secant x plus tangent x. Okay, so for this problem, again, we got 2 sides here. I need to make one side look like the other. I think you could actually work this one out either way. I'm actually going to start on the left-hand side. Yeah, you can do it the other way also if you want to. I'm going to start here just so I can show you something. We talked about the conjugate, how sometimes it's helpful to use the conjugate. If I start on the left-hand side, I can use my conjugate to show you. So just a reminder, the conjugate, I spelled it wrong, C-O-N-J-U-G-A-T-E. Conjugate is something plus something else times something minus something else. So A plus B times A minus B. Those are conjugates. And when I multiply those, kind of like I did here, you get A squared minus B squared is what it multiplies into. Okay, so I can use the conjugate to sometimes make things turn out a little bit nicer. Okay, so I'm going to do that here. I'm going to multiply this by the conjugate, okay? The conjugate of the bottom, because it's going to help me out a little bit in this case. So, and kind of the thought process here for that is, if I multiply by the conjugate, I would end up with 1 minus sine squared x, and I know 1 minus sine squared x is cosine squared x. And so it's going to make that bottom a little bit nicer. Okay, so to multiply by the conjugate is 1 plus sine x. And whatever to do to the bottom, you have to also do to the top. Okay, so then when I multiply out the top, cosine x times 1 would be cosine x. Sine x times cosine x would be sine x cosine x. Over the bottom, when I multiply this, 1 plus sine x times 1 minus sine x, you could go ahead and write it out like that, or you could go ahead and multiply it. I know that this is going to be the first thing squared minus the second thing squared. So 1 squared would be 1 minus sine squared x. And if that doesn't come natural to you to write that, you could go ahead and FOIL or distribute or however you want to think about it. From here, this is a Pythagorean identity. 1 minus sine squared of x is the same thing as cosine squared x. And on the top, we still have cosine x plus sine x cosine x. Okay, so at this point, if you'll notice, everything's in sine and cosine, so it wouldn't help at all to convert anything to sine and cosine. I don't have any identities here, but I need to get over to the secant x and tangent x. If you'll remember, secant x is, where's my formula sheet? Secant x is 1 over cosine, and tangent is sine over cosine. So if you'll notice, if you kind of think we have 2 things on top and 1 thing on bottom, I could break this apart into 2 different fractions. Both of them have, this is like undoing a common denominator essentially, kind of. So it's like I can break this apart into cosine of x over my denominator, cosine squared x, plus sine x cosine x over my common denominator of cosine squared x. And you can check and make sure if I add across the top, keep the bottom, do I get back to here? Yes. So it's like the idea of breaking it apart into this plus that. Okay, so from there, this kind of actually finishes itself out because cosine x over cosine squared x, I can simplify that a little bit. I can divide both the top and bottom by cosine. And when I do that, I'm left with 1 over cosine x. Over here, this cosine and this cosine squared undo each other. They divide out. You can divide a cosine out on top and on bottom. So I'm left with sine x over cosine x. And now this is basically our answer. Cosine x is, 1 over cosine x is the same thing as secant x. Sine over cosine is the same thing as tangent. And that's where I needed to head. That's the same thing as the right-hand side. Okay, so it's kind of a lot, I know. I hope that it's helpful. Sometimes another trick is if you can work out this side halfway and you can work out this side halfway and get to the same thing, it's essentially like doing the whole thing. So technically, let's say you got stuck at this point, or maybe even got stuck at this point and didn't know what to do. You could rewrite this, and if you ended up with the same thing, then that's a way of proving it. Okay? I'm going to go ahead and do one like that. I think I said there was only 3 problems. I'm going to go ahead and do a 4th problem, just for a little bit extra for you. Okay, so if I had the problem 1 plus cosine theta over cosine theta equals tangent squared theta over secant theta minus 1. Okay, for this one, the left and right are about the same, honestly. Like, they seem the same amount of hardness or complication, I guess. So you pick which side you want to start off with. It doesn't really matter. I'm going to start over here with the right-hand side just because I can see more things off the top of my head right here. So here, tangent squared. If I have a tangent squared, usually that means that you're either going to simplify it or you're going to use, if you have a squared, you're going to use a Pythagorean identity. Tangent squared is the same thing as secant squared theta minus 1. So I know that tangent squared is the same thing as secant squared theta minus 1. On top, on bottom, it's still secant theta minus 1. From here, I hope you recognize this secant squared theta. It is a Pythagorean identity, but I also hope that you recognize that it is a conjugate, okay, or the difference of 2 squares. This is the same thing, essentially. I hope you recognize it's this right here, something squared minus something squared, and it factors into a plus b times a minus b. So this is secant squared minus 1 squared, because 1 squared is the same thing as 1, right? So I could factor this. This is factoring it using the difference of 2 squares. And this turns into secant theta minus 1 times secant theta plus 1 over secant theta minus 1. And from there, this and this will cancel because it's the same exact thing. And so I'm left with secant theta plus 1. Okay, so at that point, I'm kind of stuck. I don't really have anything else. Like, I mean, I could change secant theta into 1 over cosine, but that doesn't really get me over here. So sometimes if you get stuck, it's helpful to start working on the other side. And if I can get this other side over to secant theta plus 1, then once they're the same, it's the same idea. Okay, so let me start over here and see if I can get this side down to secant theta plus 1. So looking at this, I can't do a Pythagorean identity because I don't have any squareds here. I can't replace it with secant or sine or cosine or anything because it's already in cosine. So if I'll notice this is 2 things, can I turn this into 2 things? Yes. If you have 1 thing in the denominator, you can turn it into 2 different fractions. So one of the fraction would be 1 over cosine theta. The other fraction would be plus cosine theta over cosine theta. And that actually worked out really nicely because now what is 1 over cosine theta? It's secant theta, and cosine divided by cosine is 1. And now that they are the same, you're done. Okay, so I hope that this has been helpful. I know it's not easy, but if you are good, you're fine with this, go ahead and get started on your homework. If you need some more help on this, I'm going to make another video, and you'll see another optional video with extra practice on it.